Hello students. So after covering a numerical on inverse Laplace transform using shifting theorem, we are going to solve one more numerical. So in this I have changed the function, that is function of s, and let's see how to find out inverse of that or inverse Laplace transform of that by using the shifting theorem. So here we have to find out L inverse of 3s plus 7 whole upon s square minus 2s minus 3. So guys, I'm sure that you must have watched my previous video, because in that I've shown you a technique. So since the numerator is a linear equation, denominator is a quadratic equation, what we are going to do is we are going to convert it in a form of function of s plus a, which I've explained you in the previous video. And to convert it into a function of s plus a, we have to find out the last term. So guys, here what is the formula of last term? So whenever we have a quadratic equation, we can bring it in the form of a perfect quadratic equation, and to bring it in that form we have to find out the last term. So the formula to find out the last term is 1 upon 2 into coefficient of middle term, that is minus 2 the whole square. So minus 2 upon 2 minus 1 the whole square is 1. Now we are going to add this last term in that quadratic equation. So we will add it and subtract it from the denominator. So here the function is 3s plus 7 upon s square minus 2s minus 3, and we have to find out L inverse of this. So we'll say that it is Laplace inverse of 3s plus 7 upon s square minus 2s. Now the last term is 1, so I will add that 1 over here. Then minus 3 is there, so minus 3, and now I'll subtract 1 from here. So I have added 1 and subtracted 1 from denominator. Now by doing this, these first 3 terms got converted into perfect square. Now guys, can you tell me what is the answer of this? So I have shown you in the previous video. I'll use the same technique over here. So L inverse 3s plus 7 upon. So to get that value, we take square root of first term, that is s. Sine of second term, it is negative, so minus, and the square root of third term, that is 1, and the whole square. You can see that expansion of this bracket is this. Next, minus 3 and minus 1 is going to give me minus 4. So guys, now denominator has got converted into term of s minus 1. So now let's convert numerator also as s minus 1, so that this whole function will become a function of s minus 1. And for that, here in the numerator we will directly write down s minus 1. So s minus 1 upon s minus 1 square minus 4. Now why we have written s minus 1 directly? Because we want to convert this whole function as a function of s minus 1, and now it got converted into function of s minus 1. But guys, wait, we have to adjust the numerator so that we will get 3s plus 7 term back. So to get this term, I will multiply this s minus 1 with 3. So this will become 3s minus 3. But guys, what we want 3s plus 7. So I got 3s term, but I didn't get the 7 term. So to get 7 in negative 3, I will add 10. So plus 10 and minus 3 will give me plus 7. And guys, now this is the function of s minus 1. And now here I'll use the shifting theorem. So this is what the shifting theorem, which says L inverse of any function of s plus a is e to the power minus at L inverse of phi of s. Now guys, here I got this as L inverse of function of s minus 1. So it means the value of a is minus 1. So here that will become plus 1. So I'll get e to the power t. So here I'll write down on the next page. So this is nothing but e to the power t, because value of a is 1, and we will get L inverse of phi of s. Now how to get the function of s from function of s minus 1? So just replace this s minus 1 with s, because guys you can see here that with e to the power minus at we have L inverse of phi of s, and phi of s is nothing but function of s which we get by replacing s plus a by s. So here I have s minus 1, I'll replace it by s, so we will get 3s plus 10 in the numerator, so 3s plus 10, and in the denominator we will get s square minus 4 because we are replacing s minus 1 with s. Now to find out L inverse of this term, I will divide numerator separately with denominator. So this will be e to the power t L inverse of 3s upon s square minus 4 plus 10 upon s square minus 4. Now guys, here I can apply the linearity property. So by using that, L inverse of first term 3 is outside. The L inverse or inverse Laplace transform of s upon s square minus 2 square is hyperbolic cos of 2t plus 10 as it is. Now here we got 1 upon s square minus 2 square. Now guys, I am writing this formula because I know the formula and you have to revise this formula, or you have to watch my previous video, that is formula of inverse Laplace transform, to understand these steps. So 10 as it is. Now I'll find L inverse of 1 upon s square minus 2 square, and it is 1 upon 2 hyperbolic sine of 2t. Now guys, 10 upon 2 is 5. Let's adjust this term, so that will become e to the power t 3 hyperbolic cos 2t plus 5 hyperbolic sine 2t, and here we got the value of the given question. So here I got a function of t from a function of s by finding the inverse Laplace transform. So I'm sure that you understood the given question. So keep watching the video so that you can learn more about the shifting theorem and the Laplace transform. Thank you very much.